All right, just a quick, video to review some concepts with capacitors. So of course we have a simple one capacitor here. So whatever potential difference there is between A and B obviously has to be between the plates on this capacitor here. So remember, potential difference means voltage, and voltage being used or consumed by something. So let's say, for instance, at point A we have 12 volts. At point B we have 8 volts, whatever it is. We know that 4 volts must be what's on this capacitor here. And of course we can go Q equals CV in order to get the volts on this capacitor. Now looking at the situation here, we have something in parallel, which means now we can go either direction here. But if there's 6 volts on this capacitor, there must be 6 volts on this capacitor here. But since they're different values for the capacitors, we know that those must have different charges. Okay, now let's take a look at this situation here where we have just a path this way and then a path going this way. Now I guess I'm assuming I should draw something else here. Let's say we have another line coming off here. Let's draw another line across here to make things a little bit more clarifying here. So now we know that these two are in series and this one is by itself, but they're parallel to each other. So let's say we have 3 volts on this one and 2 volts on this. The total volts between both of these two is 5. Therefore, this one must be 5 volts because there will be equal volts on either side of those. Okay, so what do we mean by that? Let's say there's 10 volts at position A here. At this side here, what will be left is 5 volts because we're consuming 5 volts in both of these places. Now remember, we do not add them both. We equally have shared 5 volts this way and 5 volts this way, meaning there's 5 volts left over here. Okay, now let's look at the situation here. Again, we're dealing with a situation where we have something in series with the battery. This is something in series with the battery, and now we can parallel this out here. Okay, now if this is B, and let's call this A over here. Okay, so electricity can go this way, it can go this way, and it can go this way and this way in this situation here. So now we have a parallel and a combination with another parallel here. Okay, but we do know, again, let's just say there's, I don't know, 12 volts here at position here. Let's say there's 0 volts here. Let's say this is actually ground then. Well, we know that this one would be 12 volts and this one here would be 12 volts. And there could be different volts on this branch here. Okay. So let's take a look at another situation here. We've got a situation where I've got a 2 microfarad capacitor here, another 2 in here. Let's change our circuit up, and I'm going to erase this part here, and let's just say we erase this here and we put a battery, okay, across this circuit right here. Okay, so this is a battery here, and let's draw one big line here and one small line here. Let's erase this here. Okay, so that means we have a series here with this battery. We have a series here with this battery. But when we reach here, there's a parallel in the parallel. Okay, so let's say I've got, let's say the battery itself is 16 volts. So kind of a weird looking battery. Okay, and let's say I have 4 volts across here. And again, I'm just making up numbers here, so don't worry about calculating anything here. And let's say there is 6 volts here. Okay, well, if this is a 16 volt battery, we've used 4 here, and then there's 6 here, so that's 10. There's only 6 left. So what that means is there's 6 volts across this branch, and there must be 6 volts across this branch here. Okay, because electricity can go this way around or can go this way around. Okay, so then if we look at these two here, maybe there is 4 volts on this one here and 2 volts on this. But the 4 plus 2 must equal 6 here. And then there's 6 volts that goes across here. Okay, and that's how it all works. Now again, when we look at the total of the voltage though, we add this one once. This is 6 volts. Okay, plus 4 plus 6 to give me my 16. We don't double add because this is just splitting 6 volts in this direction and this direction here. But the sum of all volts in this thing, of course, can't be larger than what the battery source is. Okay, so just remember those principles that are involved. Again, a series circuit is a voltage divider circuit. So when we add up the volts, they will add up to be the total volts of the battery. Now, of course, the charge is the same on all capacitors in series. Parallel, it's opposite. It is a charge divider circuit. The volts will be equal across the branches, but the charge will not be equal. Okay, hopefully that helps. A good summary of our capacitor concepts.